Betelgeuse's star, a crimson supergiant in the sky's constellation Orion, has long fascinated astronomers and sky admirers due to its enormous size and brightness. If Betelgeuse were situated where the Sun is, it would extend all the way to Jupiter's orbit, a testimony to its immense size. Despite being located approximately 642 light-years away from Earth, its vastness renders it one of the most luminous stars observable to the unaided eye. However, in recent times, Betelgeuse has displayed unusual behavior, like unexpected brightening and dimming cycles, which, according to many researchers, imply that the star is nearing the end of its existence. The esteemed physicist Brian Cox recently made a revolutionary announcement that Betelgeuse is rapidly approaching a terrible explosion anticipated to take place within the next 2 weeks. This phenomenon, called a supernova, will signify the conclusion of Betelgeuse's life. But it will provide an unparalleled chance for researchers to look into one of the most remarkable and potent manifestations in the universe. As a giant categorized as a red supergiant, one of the largest and most massive types of stars in the universe. Betelgeuse has been on the radar for astronomy for centuries, but its recent erratic variations in brightness have led some to believe that the star is preparing to go supernova. When a star like Betelgeuse reaches the end of its life cycle, under its own gravitational pressure, its core collapses, resulting in a gigantic explosion that releases an immense amount of energy and radiation, material into space. Betelgeuse's impending Type 2 explosion, a specific kind of stellar explosion that takes place when the core of a massive star collapses, triggers the release of neutrinos and radiation, creating a shockwave that breaks up the star. The detonation will be so brilliant that it could be visible from Earth without the requirement for telescopes, perhaps even shining brighter than the moon in the night sky for weeks or months. During such an event, typically it would result in disaster if it occurred near another star. However, the distance that Betelgeuse is from Earth, roughly 642 light-years, indicates that, although the explosion will be conspicuous and dramatic, it will not threaten the existence of life on our planet, however. The event will redefine our knowledge of supernova, one of the most powerful cosmic phenomena in the universe. It's releasing more energy in a few seconds than the Sun will in its entire lifetime. Betelgeuse's explosion will not only be an amazing stellar display, but also an important moment for scientific inquiry. Researchers are eager to learn more about this unusual event from its very onset. Utilizing a variety of terrestrial and space-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope JWST, to collect as much information as possible, when Betelgeuse explodes, it will release a broad spectrum of radiation from visible light to gamma rays. One of the most crucial supernova components will be the elusive neutrinos, subatomic particles, that rarely interact with matter. Neutrinos derived from the supernova can arrive on Earth before the light from the blast. Because of their ability to navigate almost anything without being affected, observatories like Japan's Super Kamio Kondi and the IceCube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, offering a head start in observing the final moments of Betelgeuse. In addition, the explosion will supply important insights into how heavy elements are forged and distributed when stars explode. Elements like iron, gold, silver, and uranium materials necessary for our understanding of life are created. The investigation of the Betelgeuse supernova will provide observations of this element creation process in real time, which is essential for comprehending the chemistry of the universe and planet formation. Despite the fact that Betelgeuse's supernova is not expected to have a negative impact on Earth, it will interact with our planet's atmosphere and magnetic field in intriguing ways. The energy burst from the explosion, particularly the appearance of charged particles and cosmic rays, could create more intense auroras, expanding the areas where the northern and southern lights are visible. Cosmic rays could cause disruptions to satellite communications and some Earth technology, but the disturbances are anticipated to be minor and short-lived. One of the most exciting features of the Betelgeuse explosion will be that it is observable to everyone on Earth, not just professional astronomers with advanced equipment. For several weeks or even months, Betelgeuse is expected to be the brightest star in the night sky, perhaps even visible during the daytime. This spectacle will enthrall not only the scientific community, but also stargazers and the general public. Renewing enthusiasm and interest in the universe and astronomy, astronomers have long pondered the demise of Betelgeuse. But Brian Cox's recent statement adds an unprecedented sense of urgency. In the weeks to come, observatories worldwide are preparing to investigate each stage of the supernova, as the collected scientific data will be invaluable. It's potentially transforming our understanding of stellar evolution, core collapse supernova, and the distribution of cosmic matter. Scientists will be able to use the supernova to refine their models of cosmic distances. Due to its proximity to Earth, Betelgeuse provides a one-of-a-kind opportunity to measure how the energy from these explosions moves by observing the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust that exist between stars. Astronomers will gain a clearer comprehension of the size of the universe. Specifically, the occurrence will offer a rare opportunity to examine dark matter and its potential influence over the supernova. Dark matter, a mysterious substance that makes up approximately 85% of the universe's matter, does not absorb or emit light, making it challenging to detect. However, observing the behavior of light and matter around Betelgeuse's explosion might provide indirect clues regarding the role dark matter plays in the universe's large-scale structure, the Betelgeuse Supernova. In addition to bringing us closer to understanding the life cycle of stars, particularly the way massive stars contribute to the development of elements necessary for life. It's one of the primary events in the universe responsible for the distribution of heavy elements. These elements eventually create new stars, planets, and even living things. By watching Betelgeuse, researchers will acquire invaluable data on how these elements are forged and distributed. The cultural significance of the explosion of Betelgeuse is profound. For millennia, humans have looked to the heavens for direction, motivation, and significance. The vanishing of one of the night sky's most prominent stars will encourage philosophical thought about the ephemeral nature of the universe. Betelgeuse has been a constant presence in the Orion constellation for as long as humanity has documented the stars, and its absence will be a significant reminder of the transience of all things. In various cultures, such celestial events have been interpreted as omens or signs of cosmic change. Betelgeuse's explosion may inspire a blend of awe, fear, and wonder as people from all walks of life witness a star's death. This extraordinary event is likely to rekindle interest in space, travel, and astronomy, attracting more people to the pursuit of understanding the cosmos. Already, amateur astronomers are preparing for the event in a modern manner. Technology enables nearly anyone with a camera or telescope to witness and keep track of this supernova. Having access to science will bring individuals together worldwide, observing the same thing and recording this celestial event from their unique perspectives. The explosion of Betelgeuse is not merely a singular astronomical incident. It is also a turning point for future research. The insights learned from the supernova will impact our investigations of other stars, especially as missions take us further into space, into different planets and stars, helping us grasp the life cycles of stars. The mechanics of supernova are crucial as humanity aims to be more present in the solar system and beyond. Additionally, the explosion will rekindle passion for the search for supernova and extraterrestrial life. Supernova perform a vital role in dispersing elements essential for life, such as carbon and oxygen, throughout the universe. By investigating the Betelgeuse explosion, scientists can gain a better understanding of how the building blocks of life spread, offering insight into the potential expansion of life to other planetary systems, and even the possibility of rekindling life elsewhere in the cosmos. The explosion of Betelgeuse is poised to be one of the most significant astronomical occurrences of our time. Its supernova will yield a plethora of scientific data, enhance our comprehension of the universe, and captivate audiences worldwide. Although Betelgeuse's end will symbolize the death of a massive star, it will also represent the continuous cycle of creation and destruction that governs the cosmos. a reminder that from death, new planets, stars, and even life can begin as we prepare for this historic event. The entire world will be watching the night sky, waiting impatiently for the moment when one of the universe's most potent forces bursts into view. For astronomers and scientists alike, Betelgeuse's final act will be nothing short of amazing as Betelgeuse moves toward the end of its life. It brings forth fascinating possibilities. One speculation connected to the upcoming explosion is that it presents an opportunity to highlight some of the universe's most intriguing mysteries, such as dark matter and dark energy. These enigmatic forces are believed to constitute the majority of the mass and energy of the universe, but they remain poorly understood by scientists. There is growing speculation that supernova, like the one expected from Betelgeuse, could be the key to unlocking these puzzles. Supernova release astonishing amounts of energy and radiation. Some researchers believe that this power may interact with dark matter in ways we can observe and study. One fascinating hypothesis suggests that dark matter exists as massive weakly interacting particles, or WIMPs. If WIMPs are real, their interaction with the energy released by the Betelgeuse supernova could provide insights into their nature. Such an interaction would represent a groundbreaking discovery, potentially offering the first concrete proof of dark matter, a phenomenon that scientists have sought for decades. Additionally, there is potential for Betelgeuse's explosion to shed light on the nature of dark energy, the unidentified force behind the accelerated expansion of the universe. By analyzing the behavior of energy and light from the supernova, scientists might collect important data about how cosmic events influence the universe's expansion, and how they may relate to dark energy. Such findings could revolutionize contemporary cosmology and expand our comprehension of the very fabric of space. The forthcoming explosion of Betelgeuse also provides a unique vantage point for examining the life cycle of massive stars. Red supergiants like Betelgeuse are rare in the universe, making their study crucial for understanding stellar evolution. These stars originate from vast clouds of gas and dust that collapse under gravitational forces, eventually igniting nuclear fusion in their cores. When they run out of hydrogen, they expand dramatically, shedding their outer layers through powerful stellar winds. This mass loss enriches the interstellar medium, paving the way for the formation of new stars. If Betelgeuse goes supernova, it will not only illuminate its own life cycle, but also serve as a cosmic laboratory for studying the conditions under which stars live and die. Researchers will diligently observe the aftermath of the explosion. If a black hole forms, the nature of this core remnant will provide invaluable insights into the physical processes governing the final stages of stellar evolution. The explosion itself will yield a wealth of information. The shockwave generated by the supernova will destroy the surrounding gas and dust, heating it and causing it to glow. This illumination will offer astronomers clues about the elements produced during the explosion, including nickel, iron, and other heavy elements. By analyzing the spectral signatures of these elements, scientists can determine their abundance and distribution. This, in turn, improves our understanding of how such materials spread through space and contribute to the creation of new stars and planetary systems. An exciting area of interest is the potential for detecting gravitational waves from the collapsing core during the supernova. This could cause ripples in space-time. It's detectable by observatories such as LIGO and Virgo. Gravitational waves carry crucial information about the internal dynamics of such events, potentially offering fresh insights into the physics of supernova and black hole formation. Betelgeuse's explosion could also drive technological advancements in astronomy. The expected surge in observational data will likely push the limits of current astronomical instruments and could spur innovations in imaging and real-time data processing. These developments would benefit a wide range of astrophysical studies well beyond this single supernova.